Mr. Tippesamy was a former engineer chief of Bangalore Water Supply and Sewerage Board. He had vast experience. I think he passed out from the BDT Engineering College, Davangere, if I am right, sir. And he has vast experience in the field of water and wastewater management. He was very instrumental in bringing Kaveri 4th stage and 5th stage of Bangalore water supply, Kaveri water supply. And he was very instrumental in establishing very huge number of many sewage treatment plants. I was fortunate to work under him for many years. I had a great opportunity to work with him. His vast experience in the field is very high. And I think we should be very happy to invite him for this guest lecture and share his huge knowledge to the audience. With this brief thing, I'll request Mr. Tippesamy to take over the presentation.
See on this format, basically the waste is not a waste and it is a resource. That is the first thing that we should understand. And in the context of today's scenario of the world's scenario on the water availability, I think this plays a very vital role. And on that score, I am going to speak a few minutes. Prevailing and projected scarcity of water in India and around the world. I think I am going to discuss very little on that, a few minutes on that. Circular economy in wastewater. I think today what we are looking at, so resources are becoming very dwindling, and with the result, we have to really look at how to conserve the resources together with how to recover the finances from that. I think that is what is circular economy is all about. From water and wastewater, I'll discuss a few minutes. Recovery of potable and non-potable water from wastewater. See what is happening around the world. Today, every country in the world is looking and urban areas, see recovery of this sewage, wastewater for non-potable and potable purposes is almost certain, and that is going to in a big way. I think I'll discuss much more because this particularly potable water, I think what is happening in the other part of the world and what is also trying to happen in India on potability, and of course non-potable is already there over a period of decade, more than a decade, and how this is going to be. I think I am going to discuss more on that. And we see it is not just only recovery of that water, but at the same time we are also looking into circular economy, whereby the potable water, when we supply, we are getting back the finances. We are getting back through tariff to the utility, and similarly non-potable water. And most importantly, what I am trying to discuss is about the recovery of energy as a byproduct of treating this wastewater. We can recover this energy from wastewater plants. So particularly, see, many cities are now going beyond net zero, in the sense they are generating power more than what is required to run the plant, and they are feeding this extra power generated into the grid, and they are making huge amount of money. I am going to discuss a few of the important wastewater treatment plants around the world, particularly from USA, from Netherlands, and also from Scandinavian countries. And the energy neutral is also one of the very key factor, because energy neutral is actually generating electricity to an extent of what is required for your running of the plant, because you are very well know. See, the secondary treatment requires a huge amount of power to running the either the surface aerators or diffused aeration, etc. I think energy is a very key part of treating the wastewater. And thirdly, we are going to discuss on general recovery, where most of the countries, including India, many cities are now recovering 50 to 70%, particularly recovering almost 77% of the power generated from the wastewater treatment plant. And lastly, there is, though they are recovering 50 to 70%, they are supplementing by solar and wind energy to make good and make it energy neutral. I think these are the four different type of energy energy generation, which I am going to discuss and show some case studies also. And lastly, we are also looking at, say, a byproduct of struvite. I think phosphorus recovery is also one of the very important today. See, two or three big plants, one in Chicago, another in Austria. They are generating generating phosphorus and recovering phosphorus, and also making a huge amount of money. And phosphorus is today is the most important component which is not available in the other part of the world. So we will look at in that sense. And quickly, I will resource recovery and reuse under this. See, wealth waste. I think this is exactly what we are looking at. Resource recovery. Resources are becoming scarce. I think, as I said, it is not only water. It is there is even, for example, maybe a wastewater. I mean, maybe a plastic, maybe any other material is becoming scarce, even steel. So like that, resources are becoming scarce. Particularly, water. When we are discussing this particular issue of water, every country in the world are facing a problem, and particularly, the mega cities and also the class 1 cities are facing a tremendous shortage of water. Therefore, the reason is that we all know urbanization and climate change, and this are creating a largest problem around the world. And in India is nothing to say. We are the population is increasing so badly, and we don't have the resources, adequate resources. And we are most of the cities, almost 99% of the cities, are only intermediate supply, and that too is not able to proper. So the resources are becoming scarce. So resources is becoming scarce and more attractive, and wastewater can be used as a resource since it contains many resources like organic matter, phosphorus, nitrogen, heavy metals, and thermal energy, etc. In the face of ever-growing demand, wastewater is gaining momentum to reliable source of water, shifting the paradigm of wastewater to management forum, treatment and disposal. Earlier it was treatment and disposal. So now we are looking at wastewater management from treatment and reuse. This is the change, that paradigm shift that is happening. In this sense, wastewater is no longer seen as a problem in need of a solution, rather than a part of solution to challenges and are facing today. So basically, I will show you lastly how this. I will also some show slides where you can cover your cost and running cost within no time. So I think your even we can. Wastewater can also be cost efficient and sustainable source of energy, nutrient, organic matter, and other useful by. The potential benefits of extracting such resources from wastewater go well beyond human and environmental health, with the implications of food and energy security as well as climate change mitigation in the context of circular economy. So, whereby economic development is balanced by protection of natural resources. We are also protecting natural resource. We are also making money, and that is a valuable resource. Now, some few facts about the prevailing situation globally. India, of course, 70% of wastewater is not treated. But if you look at the global scenario, 80% of wastewater is not treated. I think this is a big threat without being treated and reused. So ecosystem, everything, our water bodies are getting polluted, and we are not, even the fresh water which is available, which is also very little, is also being wasted. I think to use them also. 1.8 billion people use a source of drinking water which is contaminated with feces, putting them in risk and diseases, typhoid, dysentery. Perhaps you are aware, more than 80% of the diseases are from water. I think that we unsafe water. I think I'll also show one slide where India to lose almost 54.8 billion US dollars worth of because of the bad sanitation. In the sense, sanitation includes water supply, sewerage, and solid waste. So 663 million people still lack improved drinking water source. By 70% of population will have cities compared to 50% today. So actually, India is only 30. Short also going say close to 50%, but see in developed countries it is already than 55% of population live in urban areas. So adequate infrastructure resources and address wastewater management is an efficient and sustainable way. Opportunities from exploiting wastewater as a resource are enormous. Safely managed wastewater is affordable and sustainable source of water, energy, nutrients, and other recoverable materials, which are going to discuss in a big way. So the cost of wastewater generally greatly outweighed by the benefits of human health and economic. So it is very important. We have to live a very good life, so sustainable life or healthy life. So for that, so treatment of wastewater is very important. Providing new business opportunities also provides a great so, more wastewater than ever. The quantity of water produced and its overall pollution load is increasing worldwide. See, more we use water, more the waste generated. I think we have to also restrict our usage of water, what is optimally required for running for our usage. So this is the world scenario where 80% of world wastewater is released to the environment without treatment. See, that is a big threat, and we are losing a lot of ecosystem and also see the life of people. So, under resource recovery, I would like to. This is a resource recovery paradigm considers that most if at all, material in wastewater can be recovered and commoditized. So that is recovery of water. I think I would like to emphasize here recovery of water, reuse, recharge, alleviate water scarcity, address nutrients management goals, and other alleviate the incidence of issues via aquifer replacement. So we have three way of looking at. Of course, I'll go much in detail. But what I'm recovery of water. See, wastewater can be recovered. I'll show you one video also on this score. So that we can recover from wastewater even much better than the fresh water, even better than the quality of water which is enunciated in the World Health WHO guidelines. So it is since technology has so much developed, and recovery of wastewater for potable is also is a very important component in the days to come. I think many cities are already embarking on that. We should also, India should also look into it very seriously right now, because the situation is going beyond control. Recovery of digester gas. Recovery of digester gas can help offset and purchase electricity and fulfill the thermal energy demand. Recovery of phosphorus and nitrogen can also address this. The nutrient management goes in alleviating the nuisance of struvite formation. So apart from biosolids, see wastewater can, what is that resource recovery facility? See, we can recover biosolids, we can recover energy from biosolids and nutrient products and other products like cellulose and bioplastic. This is not in much in probably in the days to come. Cellulose bioplastic is going to be one of the byproduct which is going to be have a lot of impact on the recovery of or this thing. Now, just to give an idea of say what is happening around the world, this is the latest report on the extremely high water stress countries. Look at the India scenario. See, we are if you look at the whole Indian world scenario, I think India's position is precariously very bad. Look at the northern part, high. See, dark red is almost northern part of say the India is facing a sewage shortage. Even the southern part, except a few places. So 17 cities, countries in the world. Are facing tremendous water scarcity. This is the water resources report, Resource Institute produced by the very recent report. I think with see, coming back to only two giants of huge population, particularly see China and India. So India see has 17% of population, whereas the precipitation is only 4% of the fresh water. And see, China is only 20% of population, and we have 7% of precipitation there. So more important here, the precipitation is very limited when compared to total population. I think, see, what is it meant is that we have to be very efficient in using our water. But unfortunately, that is not happening. So, I think it is very, very important that we should look at how we can able to available water should be very efficiently used, and for that, what are the measures that we can take? That is something what really requires to be done. I think for that, integrated water a solution where all forms of water has to be recovered in order to make our country sustainable in water. So, as shortages grow, day zero becomes every day in India. So perhaps you must have learned Cape Town. Cape Town almost they have faced almost a day zero. Taps in city could run dry by 2019 after successful water saving effort. See, they have tried best to see that day zero is avoided. So, but in India, day zero has come and gone, and residents in many parts of the country where taps failed, people have turned instead of digging wells and buying water. An expanding population, growing demand of water from agriculture and industry, and poor management of water supplies have sent India's groundwater level lower levels. Perhaps I will show you some slides where Niti Aayog has produced reports on all forms of water and what is the condition of the groundwater, what is the quality of water, what potentially available water and all that. I think one should go through the Niti Aayog report of 2018. It is really scaring. I think how India is going to face water problems in days come. That reality is combined with rising temperature threatens worsening scarcity, experts say. Nearly 163 million people among Indian population, 1.3 billion or more than 1 in 10 lack access to clean water. I think that is what is the current situation in terms of the other rising population. This is one of the very, very important factor in developing countries, particularly there is a rising population and urbanization. I think perhaps you are if you go back to decade or back, I think there were only a few 4 megacities. Now there are more than 7 to 8 megacities. Urbanization is happening. Class 1 cities are also increasing. The population is increasing. Providing them with water and facility infrastructure is the biggest challenge. Climate change. This is another very important component of this reasoning for because climate change has done havoc by creating droughts and also flooding in many areas. And lastly, industrialization led to the almost unmanageable wastewater problem in India. This is leading to toxic contamination of our water sources. We must find solutions to rise. Is simply too important to be ignored. In fact, India badly needs a comprehensive national policy of wastewater management. The limited and inadequate resources we have today means that whatever resources we have, we must utilize them very wisely. I think that is our sorry. So this is exactly what today's India scenario. This is also reports from Niti Aayog, where 30% is only treated. Is not very highly treated. It is treated just for secondary treatment. Only 70% is not treated. This is a seriously very important factor. We must recover this 70% of water also. I think if you have to be sustainable. So this is a report from 2018. So there's a 40% depleted at unsustainable rate. Unsustainable rates. So it's about 40% of water is being depleted. I think around and similarly the surface water. India is currently ranked 120 out of 122 countries in the water quality index. This is the really shameful for everybody who are living in India. I think we have to make sure that all our water bodies, whether it is river or a dam, etc., they have to be has to be improved. And similarly, when supplying water quality to the citizens also need to be improved. 1/3 of India's wastewater is currently treated. I think you have seen that. Only half of the rural population has access to safely managed water. This is the report from. I mean, we are behind neighbors such as China and Bangladesh. They are much better than us. This is a very serious thing. I think all of us, all of us who are listening to, I have to make an effort in order to see how best within the given area of his has to manage and reduce this quality of water, and also, I mean, the sustainability of the water. India's water crisis. This is also a report from there. There are many reports which I'm only taking of them. 70% of India's water is contaminated. Again, that is what you have seen that 75% of households do not have water access. So 84% rural house population do not have access to the pipe water. So what I said earlier was that the 53.8 billion US dollar is lost because of the bad sanitation. Bad sanitation, what I mentioned was water supply and sewage and solid waste. Particularly water and sanitation, we are very bad management, and with the result we are all our lives are lost, and similarly our environment is very badly managed. So with the result, it is estimated that 53.8 billion, which is almost equal to 2 or 3 states equal to 6% of GDP, or equivalent to three states or 4 states budget. So we must really look at this and how we have to improve sanitation in all forms. Nutrient in wastewater plants. These are useful byproducts of wastewater as a source of resources such as energy and nutrients remain unexploited. Energy can be recovered in the form of biogas, heating, for cooling and electricity generation. Technologies exist on site energy recovery through sludge via biosolids. I think treatment process, integrated water management, wastewater treatment plants, allowing them to transition from major energy consumer to energy neutrality, which I just said. I will show you that also. Or even so, energy can also be help facilitate reduce operational cost and their carbon footprint. This is very important. When we are spending large amount of money for only power when in operation maintenance, I think when we are recovering this energy, I think we are reducing almost more than 50% of the cost of running of operation maintenance of the plant. Similarly, we can also go for we are reducing, the emission of GHG and carbon footprint, enabling increasing revenue streams to carbon credits and carbon trading programs. There are also opportunities for combined energy and nutrient recovery. Offsite energy recovery involves sludge incineration in centralized plants through thermal treatment. Technologies for recovering energy neutral is practiced all over the world. Now, what is that potential revenues, let's say, wastewater? So we can see in the right hand side, we can see water. Revenue can be recovered from, after treating wastewater can be, today in Bangalore, we are selling, treated water for non-potable users at the rate of 25 rupees per kiloliter. So that is which you are going to get. I think probably Singapore is selling at 0.8 to 1.4 Singapore dollars. I think whereas the fresh water is sold at 2.4 Singapore dollars. So almost 50% of that cost. Similarly, here also Bangalore, we are even Gujarat, they are selling in a very big way and they are making huge money. Similarly, so most of the cities, even Chennai is supplying water to many of the major industries, even as early as 25 years back. So the water for particularly for two important industries like I will get back to that particular two important companies that are supplying from last 2 years. and they are recovering, they are managing. And now the Chennai is supplying a lot of recycled water to many of the industries. Almost industries are fed with recycled water. So discharge fee from tax, the savings, that is when you are even be saved from doing that. So on the other side, if you look at the energy revenue, sale of biogas or electricity. So even you can sell biogas to see to, for example, Delhi, they're see in Okla, they're feeding it to many of the houses, more than 5,000 houses from Okla for a very long time. Can be converted to LPG or LNG or CNG, and that can be used for for various running of the motor vehicles, including cars, buses, and also trains. So it is being done in many parts of the world, particularly in Sweden and Finland and Scandinavian countries. Sale of carbon credit. I think we are because we are reducing GHG emission, we can work out the carbon credits and we can recover that. Tipping fee for collection of organic matter in co-digestion. For example, you are getting back a fat, oil, and grease if you are recovering from them, and the charges are collected from them. That is a tipping fee. So savings of using own generated in the plant. As I said, we are energy neutral, and beyond energy neutral, we are going to see when we supply water to the grid, supply electricity to the grid, we can recover that money. And whatever we are using for the plant, that is a savings. Improving energy efficiency is also another. So looking all this under biosolids and nutrients, revenue can be realized from sale of phosphorus as a fertilizer, sale of biosolids as a compost. So this in a nutshell say, we can be really, I mean, fundamentally what I'm trying to say, apart from its paradigm shift, earlier the people only thinking of treating wastewater and dispose it to the natural streams. But today we can look at, see, from all angles, how this wastewater can make a circular economy in recovering this. Potentially, the economics plays a vital part, apart from making our water fit for purpose. So recovery, see, there are three drivers: urban driver, regional drivers, and global drivers. Say water demand in services. I think demand for the areas, urban areas, there is a lot of demand. See, regional limited rainfall where we don't have a proper precipitation and all that. There is a droughts and all that, and where wastewater can be really very useful. And similarly, you see the climate change which will have an impact on getting a drought and all that. That is something more. So population growth in urban areas will have increase in cost of wastewater treatment. So increasing energy cost of wastewater treatment, because energy cost is going to be increased every year. Say from 10% to 15%. Minimum is about 8 to 10%. So that is increasing energy cost of wastewater treatment plant. See, that is also plays a recovery. I mean, that will be in your control. Increasing regulations and cost of sludge handling. That's again. So these three drivers, following the resource of recovery of drivers, will illustrate how each component will beneficial not only in meeting the demand and also recovery of precious chemicals which are very scarce. So that is very important. I think the last recovery of precious resources, that is most important, because when you don't have water itself, what is that we can, even if you have money, you cannot purchase that. So in wastewater as a renewable source, a paradigm shift is underway. As we already discussed, water is one, energy is one, another is nutrients these are the three components from resource recovery from wastewater. In a circular economy, see, all these years we were following linear economy where resource extraction, production, distribution, consumption, and waste. That we were not bothered about waste recovery. See, if you look at the bottom portion, the waste is again production, distribution, and consumption, and resource. See, this is again, we are making money out using that resource, whatever that is available. I think that is what is circular economy is all about. We are improving our economy by way of introducing circular economy. Circular economy in the world where demands of fresh water is continuously growing and where limited water resources are stress for abstraction, pollution and climate change, neglecting opportunity arising out of the improved wastewater management need nothing less than unthinkable in the context of circular economy. Achieving energy neutrality is one of the very important, although the ultimate goal is zero energy consumption, that is difficult to achieve without supplementing. See, where I go is in India and in developing countries. See, they are doing the recovery of energy, but unfortunately, that is not happening up. See, for energy neutral, completely generating electricity up to see running of the whole plant. So it may be up to 50-60%. But with FOG and food waste, winery and brewery waste, and some other high organic content waste, it is possible to make it zero energy neutral or even more. So that is very important. See, co-digestion, I think particularly FOG, I think fat, oil and grease, food waste and winery, brewery waste, etc. See, the goal is, of course, the winery, brewery, they are only making that they are generating by themselves in some of the, particularly for brewery waste and winery waste. They are instead of selling, they are generating by themselves. This goal is made more difficult where water quality requirements dictate some level of nitrogen removal, ultimately reaching net zero energy without co-digestion may be possible for plants whose permits contain only BOD and TSS limits. So this is wastewater as an untapped resource. This is the principles of circular economy, where I see we are explaining about linear economy and circular economy, what all about. But whereas sell treated water to industry or commercial complexes and realize the entire maintenance cost of treatment plant, similar to many plants in Mexico and South America. What is we have to seriously look at all the utilities in India, whether it is BWSSP or CMWSSP or say Delhi Jal Board, etc., and our municipalities, etc. They have to seriously look at how we can. I will show you one of the case in say New Jersey. Both capital and capital cost and running cost, everything is maintained by a private party. So there is no amount of money being spent by the utility. So similar thing can happen. Entire maintenance and even capital cost can be generated from that. Generate electricity self-consumption and save energy costs and sell energy and generate revenue similar to many plants around the world, similar to Santiago, Chile, and East Bay of Municipal Utility USA, and many more. So East Bay Municipal Utility, they're producing double their production and selling more than 100% to the grid. Sell recovered phosphorus as fertilizer similar to Chicago and USA and the Staris in Australia. These two big plants. See, Chicago, Stepney treatment plant produces of phosphorus every year. They are making a huge amount of money. Similarly, Australia, Staris is the place for treatment plant where Austria they are producing phosphorus. So there are many plants which are now started in producing phosphorus from the water treatment plant. Cover capital and operating costs completely similar to many cases in Latin America. Dispose biosolids at free cost are sell as a fertilizer. This from wastewater resources, I think wastewater which is generated from industries and domestic and commercial institutions, etc. They all be treated and what today's scenario is 80% is not treated. That this is exactly what is around the world. Wastewater homes and cities and industry and wastewater treatment plants. There are many type of wastewater treatment plants. Perhaps I am not going to that, but there's aerobic, anaerobic combination of that is being, many processes are there. And by treating that, treated water can be sold as we have discussed earlier. I think this is the treated water. If you can look at here, this treated water, So can be supplied to industry, can be supplied to energy sector, can be supplied to, say, for example, in Bangalore. So we are supplying energy for cooling purposes in Yelahanka. See, the diesel power plant, we are supplying 15 ml of water. I think similar to that, see, many of the power generating plants require water for cooling purpose, and for which see, there is inadequate water. Many a times it is being they are unable to run the plant because of the availability of water. So industrial processes and see, irrigation and in recreational area and replenishing of aquifers and drinking water. I think these are many areas. I'll discuss more in detail about that. What is it that sludge can be done through anaerobic digestion? We can see produce biogas and also these biosolids, and that can be, say, we can also get the carbon credit for, say, reducing that reducing the carbon emission to the atmosphere. Lastly, the phosphorus can also be recovered from as a useful fertilizer, and this is really very important, because from the point of making see, circular economy and recovery of huge financial see, the phosphorus recovery will play a very vital role in the days to come. I think we have to emulate what is being done in USA and also in European countries. I think seriously we should look at, probably it will come within a short. So from waste to WATS and how sewage could help fix India's water and energy sanitation work. I'll skip this because this sludge from thermal hydrolysis, anaerobic digestion, from digestion biogas, purification of compression by natural gas can be used for power, etc. I think see, you can see this European countries and particularly Scandinavian countries. See, we can see all this CNG, LNG is being used for running of the motor vehicles. Similarly, further separation, I think digest can be used for soil enhancement. But this is what wastewater to energy system. So today, see, even in Germany, Netherlands, and Singapore, and many other places, the wastewater is being used for, say, after thorough treatment, they are using for beer manufacturing. I think it has been said, and there are reports to say the quality of this beer is much better than the, say, fresh water. So this is a case of when they inaugurated that particular see, in Singapore. I think I'll show you. This is a see, Yum and Yak, 5 beer made from recycled wastewater, particularly from one from see, see, one in Santiago, one in see, Berlin, one in see, 2 in see, Scandinavian countries, and totally 5. You can see purest tunnel vision. Tunnel vision is from pure is also another. So like that, I think these are the brew, tunnel vision, and pure rest. So the 5 these are manufacturing. I think the details are here. I think details are here. I think California, half a moon company has recycled grey water to sink on shores, and washing machine to brew tunnel vision. That is the one. Stone brewing, and see, these are the details of each. Xylem, of course, Xylem is still in branch is there in Bangalore, and they are the one who did Berlin Weser together with Xylem created reuse of brew. These are 5 companies together with say Singapore and other thing. They have made it possible. They are using it for generation of I mean manufacturing of beer and wine. So status of wastewater reuse. I think 2 billion gallons of discharged in US water. Roughly 70% is reclaimed, and when comparison, Israel reuses more than 80%. The banking, see, Israel is 2030 up to 90 to 95% of wastewater reuse for, especially they use for agriculture. And second is Singapore. Singapore uses 30%. I understand it is 35% now. Singapore reuses 35% for up by 15% in recent years, and by 2060 they are going up to 50%. So Singapore is facing a tremendous problem getting water from Malaysia, and they are using for drinking water. So wastewater used for drinking purpose, as on today, it is 30 to 35%. So it will be increased to another 15% up by 2050. The Singapore has agreement between Malaysia and Singapore till 2060 they have to supply, but unfortunately they are not supplying the required raw water, and the result is that they are now going for this water. They have 4 desalination. They are going for reuse of storm water management, etc. In Asia is Singapore. I'll come back to that. Australia now had 20%, has a national goal of 30% by 2000. Spain recycles more than 15% and has a goal for 25% by 2020. But USA has many big projects of Florida, California, Arizona. There are more than 687 projects of in only these 8 states, southern states, particularly Florida. The Arizona. Yeah, these states are suffering for shortage of water, and they are facing a tremendous droughts over the years. So on the municipal side, utilities in water stressed region will sooner or later be compelled to investigate water reuse with the 2 options: indirect potable reuse and direct potable use. The latter sometimes is unfortunately referred to as toilet to tank. I think is tougher sell IPR, indirect potable reuse. On the other hand, is reintroduced in the natural environment and goes back to through the drinking water plant prior to distribution. Both approaches have their pros and cons, and we'll be discussing. I just told you what is most important for sustainable development for any city is, the potable water is by surface water or drinking water, groundwater, is one of the wastewater recovery for non-potable and potable water. I think the improved wastewater treatment plant, I think this is one of the key of the integrated water management, together with the storm water reuse and rainwater reuse. This is the third. So if we can really make use of all these 3 components of surface water, groundwater, and wastewater and storm water, certainly we can be a sustainable through by applying integrated urban water management as a whole. So the key point is here we are looking for 4 R's. One is reduce usage. That is most important. When you reduce our usage of water, particularly we can the wastewater generation also will be reduced. So that is most important. And removing the pollutants in the wastewater, that is most important, by way of all types of treatment processes we have, whether it is aerobic, anaerobic, or now centralized or decentralized. So many things are there, which I am very little I am going to discuss on that. And reusing that water, I think that is this is most important. Reusing that water for agriculture, whether for industry, whether it for aquifer recharge, whether it for potable reuse. So these are the areas where we are bound to do that. Each city has to do that, and recovering that resources is the last. The part. See, these four R's are absolutely essential from the point of your utilizing wastewater for our sustainable development. Sorry. So this is exactly what I explained also: reduction, removal, reuse, and recover. Prevention of reduction of pollution of source, pollution load, and volume of wastewater produced. See, today I just want to take a few minutes here. See, in most of the developed countries, they are using a huge amount of water. See, per capita water supply was 400 to 500 LPCD in USA, and even in Germany was 300 and 400. But now each one have come down drastically. See, even if you look at what is happening in London it is also it's 140 LPCD. Even Singapore, earlier it was more than 200 LPCD, 200 plus. Now it is 140 to 145 LPCD. Even in say capital of Germany, there also it has come down drastically to 100 and less than 140. So see the LPCD. See in India also we are referring 135 LPCD for see class 1 cities and also, but we are unable to supply even that 135 LPCD in many places, except a few places where see there is a possibility of getting that see by a perennial resource and all that. Like for example, Pune, where there is a tremendous availability joining to that and all. So it's we have to reduce, see, in order to make sure that the others also gets required quantity of water. Second important is the contaminants, operation systems like including collection, see, sewage treatment plants, sewage system so conveyance and treatment should be, see, where contaminants to be this different type of available to remove the contaminants, and we should do, we're depending upon the position where what is the final effluent is going to be. For example, in Bengaluru, see, we are already supplying 400 million liters of water to Kolar for agriculture, see, for feeding to lakes and also improving the agriculture around. Something like that, depending upon your quality of water, where it is to be used, I think we have to go for a particular process. Use of wastewater. Another important thing is in Bangalore, we have 2,300 decentralized sewage treatment plants in high-rise buildings. They have all big flats where they have the recycling plants. So even most of the industries, for example, maybe Infosys, maybe so most of the institutions, institutions like Indian Institute of Science or even say, educational institutions, so they're all having recycling plants. So like that, I think it is high time of utilizing this for either potable or non-potable purposes. So the wastewater reuse is also untreated wastewater under controlled conditions, beneficial use, and the reuse is most important here. I think particular byproducts reuse is only in municipal sector, which can be done by way of recovery of energy through the biosolids and also phosphorus recovery. So this is a type of treatment technology that is available. What is required for secondary effluent can be for irrigation, urban usage can be go for tertiary treatment, industrial and non-potable tertiary membrane filtration, and for potable purposes you can go for indirect potable reuse. And we are aware membrane technology is now in a big way. It's gaining tremendous momentum, and see. Direct potable reuse is again a membrane technology with high quality as put back into direct potable reuse. You just treat it and put back into the distribution. That's it. Indirect potable is again go to the put back into the lake and again take and treat it and supplying. That is a little costlier process when compared to direct potable. Anyway, I'm going to explain that in much more. See, this is exactly what. So how this wastewater is treated. And see the we get clean water and byproducts of biosolids, nutrient, biopolymers, etc. And energy is one of the very important component which we can recover. Where we can also say we need the energy, chemicals, and labor for the treatment of these things. So energy is most important, which can be recovered from this from the ultimate biosolids. That is, you can make it energy neutral. So traces of chemicals are also used for in some cases, but where mostly very little chemicals are used. So these byproducts are also very important. So where it can also be used, I told you already, irrigation, aquifer recharge, industrial process, and potable reuse. So for heating and cooling purposes, these are many areas which you can really use that. I think see industrial usage, agriculture, groundwater. What are the different areas it can be used? for industry, cooling water, water for boilers, agriculture, for drip irrigation, etc., and also for recharging of aquifers, direct injection, superficial. I say I've seen many groundwater recharge in USA. They are doing. EPA has done two or three projects, very interesting projects. And see, similarly, urban usage, there are many types of usage in urban usage, and which can be used. And lastly, this can be used for for potable usage also. Recommended for water quality, can be used for potable usage. Benefits of sharing wastewater in various applications is, see, today, if you look at the whole the particular slide, the whole of world, how much of water is agriculture, almost 32% of out of the total reuse of water, 32% is going for irrigation. Industrial usage is going for 19.3%. Landscape irrigation for 20%. Rest of them are very small quantity. Direct potable uses or non-potable usages and recreational usages, and also see environmental enhancement. You see, for these things only maximum is 6.4%, for recreation 8.3%. So this is a nutshell. What is the total usage of wastewater recovery for various applications that has been. So water use is economically feasible and attractive when there is a potential for cost recovery. So at present, possibilities of nutrient and energy recovery are among the most advanced terms of technical. Energy recovery has significant business potential in terms of reducing energy usage and operational cost. This is for agriculture. Kolar, I told you, secondary effluent being treated. This is a very huge project recently implemented with 1,500 crores. So there is many pumping stations and pipelines, and see, this way water is going to the 126 lakes and recharging them, and also in the process they are also utilizing for agriculture, etc. This is a very huge project which was done. See, about it is only very recently being about a year and a half back project has been commissioned. And similarly, there I am told that other two areas of this is from KNC Valley, Vrishabhavati Valley, and also Hebbal Valley. They are also taking to Chikkabalapur and also Ram. Status of wastewater use in the world. I already discussed this. I think I'll skip this. So plant. While I was discussing what is planned indirect potable reuse. For example, a river or a dam. See, when it is processed, we are off-taking this water from the river or a dam and bringing it to the reservoir. From reservoir, we take this and treat this water and supply to the city. And the city where wastewater generated, it will be treated. Wastewater generated will be treated, and again, they say after purification, it is again put back into the same lake, and we make a dilution, and again it is treated and supplied. So it is indirect potable reuse. So whether it is Singapore and Brisbane and many other cities have followed this indirect potable reuse, making people to not to feel that we are directly feeding the treated wastewater. So this is if it in the aquifer also, I will show you that also. In the aquifer also, we are putting back the highly treated wastewater into the soil, and again we take back and put back in. So this is Singapore. We have this wastewater is called New Water. It's a very famous. It is almost 20 years from now. They have increased from 1% to now to 35%, 30 to 35%, and that water is being supplied to Singaporeans. And it is the best quality of water. There are many reports which enunciate that Singapore water quality is even better than WHO standards. So this is the 4 taps which is represented by Singapore. 4 taps. One is desalination water by one seawater desalination. Second is rainwater through the existing rainwater. I think they have artificial reservoirs created because Singapore is a very small country. They have artificial, there was no reservoir. They created artificial reservoirs. And see, some water is imported from Malaysia, very small quantity. And this is new water. New water is something, what I am trying to say is the recycled water from wastewater. And this desalination. These are the four taps represented, which means 1,000. See, now the population in Singapore is also increasing. Now, what it was only 4 million, now it has gone up to 5 million plus. So they are see, making desalination is also one of the important components. 3 plants are there now, desalination plant. So this is again representing Singapore, a global water hub. I think the best managed see water utility in the whole Asia. I think we can see the Singapore. So this is an indirect potable reuse in in Australia, which was also done in Queensland, Brisbane. There are 3 sewage treatment plants from where recycling done with the MF and RO. Microfiltration followed by reverse osmosis. It's costed about $2.5 billion and 3 advanced pumping stations. 200-kilometer length of pipeline was laid. I will this is a 232 MLD capacity plant all put together. So see here, this is the project. I think Brisbane is it's indirect potable reuse. 3 plants from where it is treated, and what you see red, this one are the pipelines which are laid 200 kilometers. It is supplied to 2 important power stations, and rest is putting back into the reservoirs from where it is again treated and supplied to Brisbane city. Unfortunately, it is still say for a very long time that has not been utilized, but now they are utilizing because of the droughts. So there is one proposal in Bangalore which was there from 2008 onwards, which was very, very badly required. Typically today, from last 3 decades, there is no water availability, and this is not functional. Only very, very small quantities available, which is not difficult, which is difficult to see even process that water. So now wastewater from Rishabhati Valley, they want to treat it at high standards and put back, say with RO applications and all that, put back this very high treatment and put back into before and put back into the lake and say dilute it and again treat it to with membrane technology and supply it to the people. This is costing about 500 crores. 150 MLD of water can be with a short distance because only 30 kilometers. We are getting water from Kaveri, which is 120 kilometers. Instead, we can as well think of this thing. But somehow this project is being stalled for reasons which is beyond known to anybody, because this is going to be the one of the, I am told that this project was approved by Government of India as early as 2009, but unfortunately it has not been implemented. Even recently the Singapore company, one of the annexure of PUB has completely done this resurvey and done that project, and it's still not implemented. I think this is a very serious thing. We should look at, Bangalore should also do this indirect potable reuse project. So now, what is direct potable reuse? We have just now, see, we are taking this water, offtake water from the same river or dam, and this water is supplied to the city. And wastewater that is treated and to the highest degree, and again put back into the distribution system without taking back into the lake or a river, etc. And see, this is saving a lot of money, but only the quality of water should be very high standard. I think that is where see now many cities are embarking on direct potable reuse. For example, Texas or California, I think California, Los Angeles are looking at that, and see even the Santiago, they are going for direct potable reuse. So I am sure that one of the important thing is Vidak, which is more than 50 years from now. Show you. This is old and new reclamation plants in Varanab in Vidak. Vidak is see this 7 MLD plant was implemented in 1968. They have completed 50 years. This is a direct potable because they don't have any resources of potable water, and that is why they have gone in for this direct potable reuse. And recently, another 20 DPR, direct potable reuse, has been done with much more highly advanced treatment technology. I think when people are using right from almost 50 years, why we should not use? See, that too in Namibia, the capital of Namibia is Iraq, where they are using it. I think this is a very serious thing, and in India also we should embark on these sort of treatment processes. This is Vinayak celebrate 50th anniversary direct portable reuse. Celebrations was 1962, and say this 2018 October, we have taken a back look of the history of portable reuse and status quo of water supply. Join us celebrate 50 years of reuse in Vinayak. This is very, very important. I think this phenomena with global experts from Africa, Australasia, Europe, and USA have gained insight of this opportunity. What is before they call is a new water, whereas in America they call as repurified water, recycled water. I think in Los Angeles agencies, particularly Orange County Water District, allowed highly purified recycled water handed out to the free of educational tool. Around 2,000 bottles of purified water have been handed. Now they are going for, in a big way, direct potable water in Los Angeles also. So this is again an indirect potable reuse. So the treated water, highly treated wastewater, again put back into the aquifer, and in the aquifer, and after 75 days you are taking back and using for this is now many plants in in Perth and also in Los Angeles, I mean California state. So this is now becoming very, very important. I think aquifer recharging and using it for portable use is also very much there. So this direct portable reuse is there in Vidhak, as I told you. Q Cycle Corporation, these are all from USA, International Space Station, Cloudcraft, New Mexico, and Big Spring in Texas. So there is a direct portable reuse. These plants exist. Of course, this is a 50 years plant, but these plants are there from last 5 to 6 years. Clearly gives say about 40 plants what is happening on indirect and direct portable reuse, and see the examples reuse of schemes of employed engineers treatment technologies in addition to conventional wastewater technology. So you can see here you can see what type of advanced treatment technologies are used. So you can see the status. Initiation year of initiation, the project quantum of water and the type of reuse. So where it is. So these are many plants on the world. I think sequentially this is being given year wise, and this is what we should similarly think of many places in India. And Nagpur is also one of the city where they have done waste. The entire wastewater is now given on a PPP basis to industry, power generation industry, and 16.2 kilometers of pipeline for treated wastewater is supplied to power industry, where their project serves as a model for other cities in the state to follow. So after seeing Bangalore, these people have done this project. So now coming back, see the most important factor is biogas. Biogas, see what is biogas, which is recovered from anaerobic digestion. Say we have methane, is a major quantity, up to 65 to 70% is methane, hydrogen sulfide, carbon dioxide, nitrous oxide, etc. But most important component is methane. So we have to recover that methane, and that methane has to be converted into energy, or it can be converted into CNG or LNG, etc. So annual sewage sludge from 1 lakh residents can recover biomethane to power 20 buses, or 20 household waste collection trucks, or 100 cars, are saving 525,000 liters of diesel fuel. So this sludge can do so much of biogas is a powerful source of renewable energy. Biogas can be converted into electricity and heat and meet the energy needs of wastewater treatment plants, homes, and businesses. Biogas recovery contributes to combating climate change. That is very important. I think apart from all the other things, we have to really look at combating climate change is one of a very important component, because we have signed the Paris Agreement. We are bound to reduce our GHG emissions. This is one of the areas we can seriously think of. Meeting increasing demand for energy while preserving the natural resources through producing energy, biofuel, and green gas for homes and businesses. Obtain savings through generating electricity. That is very important. I think we already discussed that. To power on-site wastewater treatment facility, moving towards circular economy through recovering and regenerating energy for wastewater organic waste. So this is a 1 cubic meter of biomethane can generate about 9.94 kilowatt hour of energy. 1 cubic of biogas can offset more than 1.1 liters of petrol. So we refined biogas known as biomethane contains approximately 98% of methane. It can serve as a supply of green gas for homes, businesses, and bio power cars, buses, etc. What we discussed in the previous slide. So I think but I think this is also given a holistic approach how wastewater can be. See, this is from wastewater which is coming from the city, and also we are. So this is a sewage treatment plant from where see the anaerobic digestion. So the biogas is stored, and also this what can be biogas purification. Then you can make it as biomethane. See, this can be converted into CNG. So you can see the run vehicles and bunks, etc. So this is gives you a nutshell of how the sequentially municipal wastewater, how this municipal wastewater treatment and see multi-feedback anaerobic digestion and electricity and heat generation, biogas purification and distribution and liquefaction, etc. And say biogas, LNG, CNG, which is finally can be converted to run buses, cars, etc., etc. So I already told you beyond net zero. Beyond net zero means producing more than what running of the plant. By 2020, now recently East Bay Municipal Utility District wastewater treatment plant twice as much as electricity as it uses in USA. As it uses, I think that is a. I already told you UBM district wastewater treatment plant is generating say twice the quantity, and they are making a huge amount of money for selling the gas. I mean, selling the energy to the grid. So with the addition of new high efficiency biogas fuel turbines in early 2012, the plant in Oakland, California is already selling excess electricity. The district is probably the first of water and wastewater in the nation to sell excess electricity produced solely from waste material back to grid. So UIS project in Vienna, see this is another plant. So they are also generating more electricity, and see it's almost energy neutral, plus there is a small amount of excess energy which is also being grid. So energy is the efficiency for wastewater treatment plant. This is the first one which I showed, East Bay Municipal Corporation. So this is also 6 megawatt of power average from methane produced in the districts. And so this is again they're selling the extra energy to grid. Now here the 2 or 3 important plants which I want to share with you. Beyond energy neutral, HB in Mole wastewater treatment plant in Denmark, I think 180% of its demand, and that means see more than say 180% extra is being supplied to the. So the solution is they were earlier had only 77% of energy efficiency at power generation, but later on they added see they so they improved with the consultant, and they made it as 180% plant energy demand And today, this plant supplies extra power. The plant now generates more than 80%, 180% of energy demand electrical and heat, and has evolved the mindset from wastewater treatment plant become to energy resource plant. Surplus energy, electrical energy, back into the power grid, and hot water is also used for direct heating from the system in the location of 12 miles away. Reduced generation of biosolids and transport offsite to the fertilizer farmland, selling expertise and the technical solutions to around the world. I think this is something interesting. And here, um, population of more than 410,000 population equivalent is being treated in this thing. And this is a very interesting from Denmark. Another interesting from plant from Denmark is Billund biorefinery wastewater treatment plant. This is also getting 180% of its demand, achieves carbon neutrality. And here, importantly, we should really look at, the wastewater sludge is only used 50%. Organic municipal solid waste is also used here for 13%, and industrial bio waste is used for 37%. All put together, they are now generating electricity. And Billund Refinery, publicly owned company, provided services in water supply and sewage to municipalities of Billund, and established in 97. And the co-digesting is another very important component. So biorefinery of 2016 increases biogas production, minimize energy and consumption, of enhance the process control and improve quality. Biogas, methane and carbon dioxide currently used for produce electricity and heat. Methane and hydrogen are used for operation of fuels, and heat is used for its own consumption. Electricity is supplied back into the community. Phosphorus has a large commercial value and is supplied for the production of artificial fertilizers for 90%, for 5% of the capture. I think this is Denmark. These two plants, in my opinion, are doing extremely well, generating more than 180. This is a plant in USA, co-digestion with fats, oil, and grease, FOG. And this is also, Gresham is a very, very famous. This is also using co-digestion. Without co-digestion, very difficult. Co-digestion is very important. And in addition, so here you see 13 million gallons per day plus FOG is equal to almost 20 mgd wastewater treatment capacity, and achieving energy self-sufficiency in FOG tipping for free revenues, etc. Even they collect money for collecting the FOG also. So energy efficiency should be done first, and FOG co-digest substantially increases power generation. So basing stoke STP operating entirely in energy from sludge. This is an energy neutral plant. It's in UK. Is Thames Water revealed that basing Stoke's sewage treatment plant is now producing enough energy for waste to power and whole site after a recent 53 million upgradation of trebled its energy generation capacity. So this is another very interesting energy neutral, where completely that is from the wastewater treatment plant it is being used. In Germany, energy positive wastewater treatment plant, Hamburg Westner is more than 15% more than that. Here, you also should look at this. There are two important wind energy. I think you can see windmills. You can see here on the other side. I think that also adds addition for this power generation. So in addition, solar, wind energy, also wind turbines, almost 200 meters height, generating 8 megawatts of power also. So this is what I'm trying to say is, even if you are producing less energy, you can also supplement by other type of these things. This is what I was telling earlier. PP project in Ridgewood, New Jersey, USA, where you can entire plant. Here also you are using digester with cogeneration for 20 years, and this entire this thing is cost is free. financed installed waste holding tanks, etc. I think here you can see even the capital cost, see running cost, the PPP owners. This is a very interesting. I think even though it's a small 19,000 meter cube per design flow, I think it's energy neutrality by retrofitting existing benefits, village renewed infrastructure, no capital cost for taxpayers, so savings of so many, lower electricity cost, lower sludge hauling, etc., etc. I think you can go much in deeper when you are. So this is a wastewater to help power vehicles. This is in Scandinavian countries where say power, wastewater CNG gas is available, and where the vehicles are supplied through that gas. And coming back to Indian scenario, Chennai, Bangalore, Niloti sewage treatment plants in Delhi. So these are the three plants where I think some more are coming up in Ahmedabad and say other places. I think Chennai is the one very doing very nice from last more than a decade. I think this is Bangalore. Bangalore is only one plant is there, 60 MLD plant at Kenshi Valley generating power. But there is a tremendous potential in Bangalore water supply and sewage board to produce energy in already there are almost 30 plants are there. I think they should seriously consider how to realize energy from these plants. I think this one is not enough, and that it should be a very serious thinking on by management to go in for that. I think this is a Chennai power generation plant where you can see here Perungudi, Nesupakam, then Kodangayur, Coimbatore. These are the four plants. I think this digester followed by hydrogen sulfide elimination. I think followed by gas engine injector, scrubbers and gas engine. This is what exactly is in all the places. There are now one more is also introduced, I am told recently. This is the extent of power generated in Chennai. So, you can see the almost 63.25 crores of worth of power they have generated over a period of time. I think this is a well illustrated thing. I think every city, particularly mega city and major cities, should think of doing these things and generating power and making energy neutral. I think this is IW reports as he look at other cities recover significant portion of energy from wastewater include Bangkok, Chennai, Kampala, etc. I think I have recently received information. I think this a big report is from IWA where so this is a power ultra membrane gas storage system where gas can be stored by this is the latest thing with a double biogas storage material. I think membrane storage. So phosphorus recovery. I think the last portion I take another 5 minutes. Wastewater typically contains large amount of nitrate, particularly phosphorus that can pose harmful threat to fracture infrastructure. And today recovery process offers municipalities opportunity to generate revenue while providing agriculture businesses with the refined usable phosphorus and increasingly scarce natural resource. I think this is very important. As I already told you, scarce resource. It is not available every place. It is only available in 3 or 4 countries in the world. Now we see last 1 decade it has increased by 500 times. Moreover, it enables wastewater entities to serve more than just treatment facility, but ultimately as resource recovery agents, transforming perception wastewater treatment. So Metropolitan Water Reclamation District of Chicago, I told you this is a one big plant. Chicago and Astara, largest nutrient recovery plant to recover phosphorus and project Mississippi River Basin, setting a bar as a wastewater stewardship recovery of reuse Metropolitan Water Reclamation Plant. And this Metropolitan Water implemented transfer facility into resource recovery, providing significant environmental benefits to Chicago area water system and downstream to the Mississippi River. I think just followed by this is the world's largest nutrient recovery facilities, produce valuable environmentally friendly fertilizer. So the 10,000, you see, facility has production capacity of 10,000 of high value. Recently, I have also uh, listened to the person who actually manages this very fantastic project. This is a Stickney plant. I think Stickney plant, water reclamation plant, together with the recovery of wastewater. I mean, phosphorus. I think this is so. This is how the uh, high quality slow release form, which can be sold to stores and used in fertilizers, market as crystal green and recovered fertilizer, will providing revenue for the metropolitan water reclamation. It's not a burden, but a valuable resource. So this is the last but one slide. I think I told you. In Australia, they have done some study where see they can recover how this will become a really a profitable job. For example, water, 1 cubic meter of wastewater can be converted into zero this thing, and see then ultimately what is its value? Nitrogen, methane, organic fertilizer, and phosphorus. If you can all do that, I think you can see that there is a big see when you finally think of see running of a plant. I think this is a paradigm shift where everybody should realize. And only thing is, if we should put some money as a capital and put all these recovery process, and ultimately you are certainly going to get see the. So this last slide, carbon neutral wastewater treatment plant in Keynes. Keynes, perhaps all of you know, this is a place where every year some filmy this thing is run in France, in and, there. So the 180 MLD plant is 100% solar energy. You can see everywhere, all the plants, all the units are covered with solar energy, solar panels, and see they are using 100%, and this is we can call carbon neutral wastewater treatment plant. So I think you can we can also think in these terms, and where energy can be the one of the when we can get energy from solar wherever it is practically worth utilizing solar energy. So then the last one is take home message. Sorry, take home message is wastewater is increasing worldwide. We told you that because of the population that we should restrict that wastewater, but still it is increasing. Majority released without treatment. Affordable, low-cost treatments are available. Reliable and sustainable source of water is most important. See, UN has come up with 17 sustainable goals. I think perhaps all of you know UN. I think out of that, 6 is most important water, and under that 6 there is again sub branches of 8. So sustainable source of energy, nutrient, other recovery by byproducts is very important for a sustainable source of energy and nutrient. And in circular economy, wastewater use and byproduct recovery can generate new business opportunity while helping finance finances, sanitation services. The cost of improved wastewater management are outweighed by benefits in terms of human health, social economic development, and environmental sustainability. And lastly, the essential for achieving the 2030 agenda for sustainability. That's exactly what I was telling you. 2015, they have come up with the agenda of sustainable development of 17 goals. Out of that, this we have to achieve this if we have to really make these things to happen. Thank you very much. I think this is the end of my slide. And if you have got any questions, you are liberty to ask me. Thank you.
Thank you, sir.
Yeah, Shikumar, you can continue. Yeah.
Thank you, sir, for your presentation and taking your time and giving us such a nice information on different aspects of wastewater treatment, and also how to make a sustainable plant by doing a lot of energy recovery, and also getting a lot of resource getting recovered, not only in terms of wastewater treatment, but also uh, showing us the chemical recovery as well as the aspects of bioenergy recovery and so on, and also showing all the several plants which has been commissioned worldwide as well as in India. I think if there is any questions, we will take from the participants.
Yes, sir. Hello. Am I
Yeah.
audible?
Tell me, madam. Yeah, you are audible, madam.
Yes, sir. Myself, Dr. Anupama Rajput, sir. Sir,
Yeah.
your talk is very informative and it is very useful for us as well as environment. Sir, one question coming in my mind, that is, how can we reuse of RO wastewater? Generally, we have use in RO in our houses, so there are so many water is wasted. So how can we reuse this water, and which technology and which methodology are used for the treatment of RO wastewater?
No, incidentally, see, RO basically is practiced. RO practiced almost all cities. You see, 121 countries are practicing RO, particularly in desalination for in mega treatment processes. Look at UAE and see these areas. Almost 50% of the world's treatment is there in the point is most of these people they try to after they are putting back into the sea today. That is also a big problem that they are envisaging. The basically the the even the sea, they are facing a problem of this biological biological aspects of the creatures are also getting see vanishing, and thereby then there is also a big threat on how this waste has to be treated. And so for a small plants, for example, there are many portable uh, plants in every house which they are using for drinking purpose and other places. They also get almost 50% of rejects. These rejects are again they are putting back into our sewer system. And in case of rural areas or peri-urban areas, they are putting back into the environment. See, this is traditionally, I think it contains a lot of, not only in terms of other type of, that physical, chemical, bacteriological, and parameters are very high, and particularly even TDS and microbes. Unless you treat them, I think it will. We are only spoiling our environment and also our water bodies. So we have to treat them. This brine, I think we call it as a brine. I think this brine need to be treated before it is discharged into the environment. I think there are methods of ion exchange. There are so this desalination. Sorry, these RO plants. See the three parts. One is portable, and second one is there are also plants with smaller mid capacity and large capacity. Of course, large capacities are all only in adjoining to the sea, and see these micro and macro, mega. I see they are also they are leaving it to either our rivers or into the atmosphere or to the lakes nearby, etc. I think we should treat that before it is. So it should be made a mandate. I think that's very important. I think the government of India should take seriously, and pollution control boards, because these rejects contains very hell of pollutants to this our environment and also our water bodies. Okay.
Sir,
Thank you,
actually,
sir. Thank you.
Sir, actually, the madam is asking, I think in domestic water treatment, there are some ROs have been used that reject how we can manage. So that's what, madam, I think they are asking.
No, that's exactly. I think you can use it for your agriculture. I think that's only the way. Other than that, you should not supposed to leave even into our sewer system, because it contains very high pollutants. Uh, say particularly
Yes,
why
sir.
I'm telling.
Because sir, this type of water contain various type of dissolved salts, and so many contamination is there. So we cannot use directly into the plants also.
Yeah. So I partly agree with that also. So I think they have to find. See, there are different technologies rejects to be treated. I think it is very difficult to afford that the cost for treating that, and space and space are also important. But there is no shortcut of reducing that quality of water. I think they have to find a place for treating that. I think that's the only way. I think that I don't have any other way to suggest you.
Yes, sir. Thank you, sir. Thank you.
Thank you.
We have another question from TG Murli, sir. He
Please,
says that
please.
the modernization of different various techniques for wastewater treatment, is membrane technology one of the feasible method for wastewater treatment as per the WHO standard?
No, see, coming back, I think this is one of the way. I think the perhaps you have seen, see, right from conventional technologies, right from wetland process up to membrane bioreactor. See, point is the costs are very, very important. See, low cost technologies are there, high cost technologies are there, and ultimately the space or many other factors will come into picture. Finally, what is most important is, so you want a quality of water. If you want to do that, I think membrane technology today is the highly advanced membranes. See, different polypropylene membranes now replaced by ceramic membranes and so many other things. Gradually, the cost of membranes are coming down drastically. Similarly, energy consumptions can also be reduced by way of this recovery of energy, etc. In another 5 years or so, or maximum 10 years, so these membrane technology, I think, will be outweighed by the conventional technology. That is what I could see, because technology is innovations are happening in every day in the wastewater management. I think MBR is the now today is the technology which is in even in MBR also anaerobic membrane. So is also anaerobic membrane reactors are also coming up, whereby energy is also. See, there are two important factors in in MBR or any membrane based see technologies. On the cost of the membrane, another is electricity. So otherwise, see the land costs are so much less. Only 25-30% is enough to compare to conventional technology. So comparing all these things, we have done a lot of, comparison studies are available. But the days to come, I am going to see that membranes are going to play a very vital role, and different types of membranes are coming up, and the quality of final effluent today is most important. For example, see the water quality at we have at Kaban Park we have a 4 MLD plant which is working from last 12 years. You can actually drink that water, though it is not RO ultrafiltration. It eliminates all your pathogens, and also your there is no TDS level also. TDS are much lower than that. So in the days, even Infosys has 3 MLD plant in Mysore, Bangalore, and several other places. These plants are there. MBR is going to drive in the next 5 to 10 years.
Okay. So
Membranes are going to play a very.
there's one more question from Ragini Krishna. She
Yeah,
says
please.
that can wastewater management system be a decentralized manner, so that the treated water can be pushed into the local lakes and thereby increase the groundwater recharge? What would be the cost for setting up such plants?
No, I fully agree. Today, the concept has totally changed what it was about 3 decades or 4 decades back. Centralized plants versus decentralized plants. Of course, there is a lot of advantage of decentralized plants. I already told you. In Bangalore itself, there are 2,300. I got an information from a pollution control board. There are 2,300 plants, decentralized plants. Capacities varying from zero point 0.5 to 5 MLD. So these plants are located in almost all the housing complexes, big housing complexes, educational institutions, commercial complexes, etc. So these plants, definitely decentralized plants are worthy. Even for municipal section, it can also be done provided space is a constraint. But you can still think, see, I have seen plants in France and also in Japan where you can go below level plants are being installed. And see, if you can do that, I think decentralized plants can be located at different locations, and that water can be utilized for various purposes, for non-potable and potable purposes. I think days are not far off. I think that decentralized plants are going to drive, see, compared to centralized plants. Of course, in Bangalore, you can see KNC Valley, they are all 13, 14 kilometers. They were located 14 kilometers or 15 kilometers away. And long distances of pipeline, huge diameters of pipeline, and maintaining those also is a big problem. But in decentralized plants, it's the question of only the space, and so the utilization of this water is two important components. Probably that is not an issue once the authorities or they would take a decision for going to decentralized plants. But there is already several, I told you, there are several decentralized plants, not only in Bangalore, but also in other part of India also.
Oh, thank you, sir. Any more questions from the participants?
Yeah, I'm Amit Kumar Mittal. I got a question. I'm working in military engineer services as a chief engineer.
Yeah, please tell me, sir.
In my opinion, there is a need to add one more R. That is review, or you can call it audit, of existing water supply scheme and treatment system and technologies. What is your take, please?
No, I say there is no iota of doubt. I can do that also. I am only see in triple R also being made. Say now I have introduced 4R. You can introduce another. No way. I think it's definitely acceptable, and particularly the authorities and the institutions out with these solutions by way of putting it in their policies and programs. I think I agree with you. I agree with you. There is no.
Thank you for your appreciation. See, my point of view is that only, like, it will introduce a lot of energy efficiency and reduce a lot of wastages. Yeah.
I agree because see many plants. Many.
Just wanted to share with all the participants also. It was not a question, in fact.
Yeah, you can
I totally agree with you.
Thank you.
The point is.
Thank you. Thank you so much. Thank you for a wonderful lecture. Thanks a lot.
Thank you.
I think there are no more questions.
Hello, sir. Sir, one more question. Last question. I want to ask Murali.
Yeah,
Hello.
yeah. Please tell. Please tell.
Sir, a very good informative session you are given. Very good. We got a good knowledge on this one. Sir, one thing, in foreign countries they are using that water, the recycled water, they are used for the domestic purpose or for agriculture purpose, or that water is tested as per WHO and they'll use it for the, that one I want to know.
No, for example, see, I told you Singapore today, out of 1,440 million liters, 30%, almost 450 to 500 million liters of water with indirect potable reuse is used for drinking purpose. In the sense, there,
sir, water complies the WHO standards.
That's what I'm telling you. Just a minute. See, point is, see, when they first installed, see, the WHO has sent a team of 6 expertise to study the quality of water, and that is available where they say it is better than the WHO standards, WHO guidelines. So Singapore, I'm Singapore. Similarly, Brisbane has done a 232 mld indirect potable reuse. There also they have found that the quality of water is much better than the regular water supplied by the Australian authorities. So now there are other places in Texas and Santiago. They have done pilot plants of 20 mld just to showcase them and to the VVIPs, and they have got a very good response. And even in California, so the California 90% of the people have accepted for direct potable reuse. The survey I didn't show you because there are another 500 slides are there with me. So this latest thing is California, Los Angeles and California interstate, they have stated that 95% of the people are agreeable for going for a direct potable, because those states are for water, and droughts are continuing over a period of time. So I'm sure that quality of water has to be much better than or equal to the water's the standards. The US EPA standards are there. Each country has their own standards. It should be the same standards or much better than that. Then only it is acceptable.
Okay. Thank you, sir. Thank you.
Sir, I have one question.
Yeah, please go ahead, madam.
Sir, I'm Ruxana from Kerala. So I have done a survey regarding the perspective of public in reusing this water for direct use. And most of the people are highly reluctant to use the water for potable purposes. So is there any suggestion from your side to educate the public for reusing the water for direct use, like introducing some concept in the syllabus or something like that, to educate the students from the students from where they are getting educated to use the water for direct use?
No, it's a very good question. I think in India, still people say, I told you that Bangalore Water Supply and Sewage Board 150 mld plant was almost approved for 500 crores. And that day, the government, BJP government, I don't want to say about, but on that day, 2008, they rejected mainly because it is not accepted to the people. See, you have to create awareness among the people. Outreach, we have to go in a big way. I think I have one slide, one video, 8 minutes video. If you have time, I can show you that, which anybody you see that video will agree that the quality of water of any surface water or groundwater, this water is better than that, and they can easily accept that. But point is, you see, even in many developed countries, for example, in Berlin, so they have outreach programs continuously going on, and bringing awareness of the people about the quality of water, about the quantity of water, availability of water, and all that. There is 8 or 10 the mobile units are provided, which they continuously go and to different places and campaign show on all these areas. So it is necessary in India. We are not particularly the politicians and the bureaucrats have to make their thinking very serious. If they have to really make this type of thing, people will not accept, because toilet to tap, we call it as toilet to tap. The direct potable reuse is called toilet to tap, which is acceptable in California, which were there dead against over a period of time, in Texas and also in Santiago and also in Florida state also. So you can the situation there, and when the things are going beyond control of the availability of water, they have to think in these terms. Of course, you have got a very good water precipitation, and that is why people are the potential is there. People are against that, but certainly you start with the non-potable reuse. For other potable reuse, then you can shift it to potable reuse. So campaigning is very important. Awareness and outreach programs. With all these welfare associations, NGOs, CBOs, and also mobile vans. There is, as I told you, YouTube. I think there are many videos are available to showcase how this recycled water is fit for drinking.
Yes,
I have
yes, Yes,
Okay,
sir.
I think we will end this session, sir. Thank you so much for your
Yeah.
patience and answering all the questions. And I think CT Puttaswamy sir has taken a leave for some other meeting, so we
Yes,
will
sir.
Okay.
end the session. And I think I request all the participants to join back for session 3, day 3 at 2.